Assalamualaikum warahmatullahi wabarakatuh. Hello everybody, my name is Rika Oktavia Pratiwi. My ID is 37. I presenter 12. Now I want to explain about review of chemistry article with the title is Preparation and Characterization of Nickel Copper Composite Nanoparticle for Conductive Paint. Why did I choose this article? I choose this article because it discusses nickel copper nanoparticle, which are the two most promising alternatives for precious metal used in electrically conductive materials, where this experiment will be used as an application in making conductive paint. Next, my review article, there is structure review, content review, and my conclusion and suggestion. Okay, the review, structure review. The title in my article is Preparation and Characterization of Nickel Copper Composite Nanoparticle for Conductive Paint. And the author Liu Yang Bai. Okay, we'll let's to the keyword is metallic powder, composite nanoparticle, electrical conductivity, and oxidation resistant. Okay, we let's to the abstract from this article. Nickel and copper are the two most promising alternatives to noble metal used in electrical conductive materials. However, copper is susceptible to oxidize, while nickel exhibits poor electrical conductivity. To solve this problem, copper-nickel composite nanoparticles have been prepared in the present work by successive hydrogen reduction based on the different oxidation potential between copper 2 and nickel 2. The S prepared products were characterized by XRD, FESEM, EDS, and TG, and the electrical resistivity of which was measured by four probable methods. A formation process of the composite particle was proposed and demonstrated. The copper-nickel composite nanoparticles have a uniform diameter of about 15 nanometers and exhibit higher oxidation temperature than copper and lower electrical resistivity than nickel. This novel nickel-copper structure and method might help solve the problem associated with the oxidation of copper and the low electrical conductivity of nickel, which would further promote the application of base metal conductive powder. Next, the introduction. Composite particle combining two or more components in each individual particle usually exhibits novel or multiple properties and hence have much broader application than the homogeneous single component counterpart. Therefore, new strategies to prepare composite powder have attracted considerably increasing attention in recent years, particularly if they are straightforward to implement and can be applied to potentially useful material. Okay, we'll relate to the material and method. Is all analytical chemical reagents were obtained from Beijing chemical reagent cobalt and used without further purification. Typically, an appropriate amount of nickel chloride 2 and copper sulfate 5 and copper sulfate 4 were dissolved into 100 milliliter of distilled water to get homogeneous equal solution with a total concentration of 0,1 molar. The molar ratio of nickel chloride 2 or copper sulfate 4 was controlled at 1 epil 0, 2 epil 1, 1 epil 1, 1 epil 2, and 0 epil 2 for nickel 2 copper 1, nickel 1 copper 1, nickel 1 copper 2, and copper, respectively. The solution was heated in thermostatic water but till the temperature reached 80 degrees. Okay, the next review the structure, result and discussion. First, reduction process. Hydrogen is powerful chip reduction widely used for the production of the metallic powder. The hydrogen reduction process can be given equal 3. You can see my PPT on my PPT. And second, characteristic of the product. All diffraction peaks were attributed to copper and nickel, indicating that not only copper but also nickel can be obtained in the present system. With the increase on the molar ratio of nickel or copper, the diffraction peak of nickel will significantly enhanced. When a ratio nickel or copper is 1 is used, the peaks of copper and nickel cannot separate clearly from each other and exist as almost 1. However, it can still recognized in the high-score software as nickel and copper, respectively. On the other hand, the main peaks of nickel 1, copper 1 is perfectly agree with that of copper instead of between copper and nickel. Therefore, overlap of the peaks attribute to the little distance between them instead of information of alloy. You can see on my PPT the picture in reduction process and characteristic of the product. Okay, we let's to the conclusion from this article is a novel nickel copper structure was designed and the composite powder were prepared by successive hydrogen reduction. The powder were composed of will dispersed nanoparticle and the particle size is about 50 nanometer. The distribution of copper and nickel pairs are homogeneous within the powder. The composite powder exhibits higher oxidation temperature than copper and lower electrical resistivity than nickel. The innovative product might have potential application as conductive particle. This work might help solve the problems associated with the oxidation of copper and the low electrical conductivity of nickel, which would further promote the application of base metal conductive. Next, the acknowledgement from this article. This work was financial support by the National Natural Science Foundation of China. Reference for my article you can see on my PPT. An appendix in my article none. Okay, next, content review. There is purpose, the material and method, the result and discussion, the conclusion, and my conclusion and suggestion. Okay, purpose, my article is the aim of the research in this article is to overcome the problem associated with the oxidation of copper and the low electrical conductivity of nickel, namely by using copper particle cooled with nickel on the surface of copper nanoparticle without reducing their electrical conductivity, as well as electrical conductivity and resistance to oxidation. Then, in this study, using the reduction route is in succession. Okay, material and method in my article. Used in this research, typical and appropriate amount of nickel chloride 2 and copper sulfate 4 were dissolved into 100 ml of distilled water to get homogeneous equal solution with a total concentration of 0,1 molar. The molar ratio of nickel chloride 2 or copper sulfate 4 was controlled at 1:0, 2:1, 1:1, 1:2, and 0:2 for nickel 2, copper 1, nickel 1, copper 1, nickel 1, copper 2, and copper respectively. The solution was heated in thermostatic water bath till the temperature is 80 degrees. Then 2,5 ml of N2H4 was injected into the solution. The mixture was stirred and held for another 1 hour. After cooled to room temperature, naturally, the precipitate were filtered off and washed with distilled water and anhydrous ethanol in sequence and dried at 60 degrees for 1 hour. And each tree can be used for adjusting pH. If one wants to reduce the amount of N2H4 in order to obtain pure nickel powder, the amount of N2H was kept at 1,7 milliliter, and sodium oxide was supplied with the molar ratio of OH. The method used in this research is straight line vertical for probe method at room temperature. The constant current was supplied through a Hall measuring controller, and the voltage was measured by a nanovolt meter as shown in figure 1. You can see my PPT for figure 1. Okay, the curve following through probe 1 and 4 for the figure 1, and the measured voltage between probes 2 and 3 is V. The distance between probes are L1, L2, and L3 respectively. The conductivity of the electrode can be calculated by the following equation. You can see on my PPT. Okay, next. Okay, we let's to the result and discussion. First, reduction process. You can see picture figure 2 on my PPT. There is figure 2 illustration an ideal formation process of the composite particles when copper 2 and nickel 2 CO exists in the hydrogen reduction system. Step in schema 1, copper 2 would be reduced first and from copper particles. Step 2 in schema 1, and then the newly formed copper particles act as nucleus and triggers the reduction of nickel 2. Step 3 in schema 1, because nickel 2 is stable in the present deposition system without copper, no homogeneous nucleation could be observed when the nickel plating solution was heated for 1 hour. Therefore, it is reasonable that the former formed copper nucleus played the role of nucleating again, and the latter reduced nickel deposit on the surface and formed nickel coated copper composite particle. Figure 3. You can see figure 3 on my PPT. Figure 3, A and B are photos of He foil before and after nickel plating. respectively. The Si foil after coating by nickel looked so smooth as before, but the color turned dark. Figure 3C is a picture showing the magnetic properties of nickel-tipped Si foil intuitively. Figure 3D is the SAM image of the cold Si foil surface, and figure 3A is the corresponding ADS result. Second, characteristic of the product. Figure 5, you can see in my PT, figure 5. Okay, figure 5 show XRD patterns of the product obtained with the molar ratio of nickel or copper at 1:0, 2:1, 1:1, 1:2, and 0:2 respectively. All the diffraction peaks were attributed to copper and nickel, indicating that not only copper but also nickel can be obtained in the present system. With the increase of the molar ratio of nickel or copper, the diffraction peak of nickel was significantly enhanced. When a ratio nickel or copper is 1 is used, the peak of copper and nickel cannot separate clearly from each other and exit as almost 1. However, it can still record because using in the high-score software as nickel and copper respectively. On the other hand, the main peak of nickel 1, copper 1 is practically agree with that of copper instead of between copper and nickel. 3/4 overlap of the peak attribute to the little distance between them instead of formation of alloy. The resistivity was measured by 4 probable methods, and the calculated results are given in table 1. The resistivity of copper powder, nickel 1, copper 1, and nickel 1, copper 2 compost powder, where you can see table 1. Conductivity of copper, nickel 1, copper 1, and nickel 1, copper 2 powder. Okay, well, that leads to the conclusion from this article. I have read the conclusion of this article in the review section of the article structure. You can read my conclusion in my PPT. Okay, next, my conclusion and suggestion. After I reviewed this article had all the structure of the article. I can conclude that this is a good scientific article. This article can help solve problems related to copper oxidation and conductivity electricity from nickel, which will further drive adoption conductive powder of base metal. Okay, that's all I can say about a review of chemistry article. Thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.